Okay, we're live everywhere.
Hey.
Well, here we go.
Amazing. All right.
Andrew, there was no woohoo. Oh no, he's frozen. So frustrated. Pick us off until Andrew makes it back. This is this one time.
Uh-oh.
Okay. He's still frozen. Okay, sorry. I was making sure we were all muted. Andrew, major technical difficulties, and we're not even in the same city. Internet is failing us miserably, sadly. And of course, Andrew's the one who has all the pictures. I can pull them up at some point in time if we need to. But welcome back to this is episode 17 and number 2 in a 3 where Aidan gets to tell us all how he's fixing some big bird problems, make it run more efficiently.
Here's what I found.
Oops. Talking to me, seriously. It's like, is it Friday the 13th? It's so, things are going awry. No problem. Here at Urban Machine, we are on a mission to to reclaim half of the 37 million that go into landfill every year. And, we're doing that. What our robot does is it automates the process of removing metal fasteners from wood that comes out of demolition, deconstruction, construction projects, so that we can reuse that wood again. Really awesome stuff. You joined the team in April? Is that right?
April. Yep, early April.
And so you've seen quite the growth. You and I talked about this a little off camera last time, that you've been watching, you came into this project, things were established, and now there's been a shift.
So basically when I joined Urban Machine, there was like a set machine architecture or like footprint about what the machine did look like, and since April we've done 2 deployments to real world recycling facilities and lumber yards to reclaim some of that lumber that Jory mentioned. We're trying to reclaim some of that used lumber. So since I've joined, we've done 2 deployments with the old machine architecture, and now we're kind of at we have the opportunity to rethink what the machine looks like for the first time since I've been here, completely from the ground up. So that's kind of where we're at, and that's why this segment is why we're doing this one time right now, focused around the big bird.
That's right. And the first one in the series, this 3-part series, you told about. You want to recap that really quickly?
Yeah. So basically, there is, in order to remove the fasteners from the wood boards, basically we have a gantry, which is a 2-axis plane of motion, and then we have a 3rd axis which extends to pull and push into the wood in order to grab the fastener or locate it, essentially. So the problem with our previous Z actuator, which is what we're calling it, is that basically it's under-spec'd, so it can't perform to the level that we need in terms of loading, in terms of speed, and especially recently we realized in terms of its lifetime. So that's where, yeah, that's what we're gonna work to solve that during this one time round 2 and 3. So hopefully that's a good segue into this week.
And ultimately, for clips, notes, versions of that, when the bird would miss a nail or staple, it would have to return to its original position, then come back. Now,
Yep.
without having to return to its nest.
Yeah, it does it. Yeah, it won't need to home anymore. That's for sure. Which will be a big time savings, and there's some other smart things we can do. Well, that we'll be able to do with this new architecture of like motion control and of the actuator. It'll be a whole heck of a lot more. Give us a whole heck of a lot more feedback into what we're actually doing. So.
Right.
It'll be smarter in a way. So it's really exciting for us.
For sure. So okay, the last 2 weeks. Yep. What do you know now? Didn't know when we met last time.
So over the last 2 weeks, I've done a good job of hopefully maybe a good job of nailing down the requirements for this actuator. So let's start there. I've done a little bit more, but Andrew, I'm not sure if you're able to show the images of there's the one where that shows the extend and the retract with the bars. That highlights the requirements of the actuator during its 2 main motion cycles. So this is the retract cycle. Basically, what this little visualizer here is supposed to do is to help you visualize how long certain segments of the motion will take. On the top here, this one's for time, and it also shows you the stroke of the actuator, so how long it is and where it is. So this is highlighting that we're going to move from 300 millimeters to 150 millimeters. Obviously, this isn't to scale in half a second, and that's this section kind of highlights the section where we could potentially be pulling a nail out of a board. So we want to be able to complete that in half a second if that is a really long nail. Obviously, we see all sorts of lengths of fasteners, but basically this top bar here highlights how fast we want to be able to pick, and the bottom bar highlights the loading cases we want to be able to deal with. So when we're retracting, we're moving from 300 millimeters to 150 millimeters. So we're extended, we move back a little bit, we're pulling this nail out. We could potentially see loads up to 4,000 newtons, which is 900 pounds. And this is a little bit of overkill, but in terms of like the loads we might actually see. But you always want to work with some like a pretty large safety factor, especially when you're working with industrial equipment that's going to be like beaten, and it needs to be very, very robust. So yeah, and then this other section that you see, which says continuous at 15 kilograms to 25 kilograms. This is basically when the actuator is moving without it, when it's not trying to grab a nail, when it's just moving with its payload, which is like whatever tooling is on the end of it. So that kind of sets out the requirement for the retracting forces and speeds. And then Andrew, if you can go to the red one, yeah, this one basically highlights the requirements for the extending speed. So basically, we want to be able to extend in under a second, and then basically the main zones here that I've highlighted are 0 to 275 millimeters, and then 275 to 300 millimeters. That zone there is the zone where the tool might be interacting with the wood surface or digging into the wood surface for nails that are below the surface. So that's our main like highest loading condition, and that kind of sets the loading like the that kind of sets the specification for loading for this entire cylinder. So when we're digging into the wood, we want to be able to dig in with a very high force, similar to something that you might get out of a hydraulic cylinder. And then when on the extend, when we're not digging in, we're just moving around with our tool payload, as I mentioned before, on the retract side. And basically, so what happened was, do you guys have any questions before I can keep going? But yeah.
No, I understand, and obviously the just to clarify layman's terms, of course, that's what I'm here for. Is to dig into the wood is obviously imperative. You're going to have nails and stable above board, literally.
Mhm.
So
Yep.
it has to dig in, and I know right now it's like 1/8 of an inch. Is there a different goal, or is that still the same?
Yeah, so I think the goal we set for ourselves is to dig in 20 millimeters, so almost a full inch into the board for this next version. Um, Whether we get there will depend on a lot of testing of this thing, but basically what this like high load, high force actuator is going to allow us to do is to try a bunch of different things and see how deep we can really get into that wood to retrieve a fastener. And it's worth noting as well that our goal is to minimize wood damage while we're getting that fastener out as well. But obviously the wood we reclaim needs to be metal free. So that's the primary goal, and the secondary goal is to reduce any damage to the wood itself.
Gentle giant.
Yeah, and this is really where the current system, digging this deep is a challenge. And one thing that we've seen is that these fasteners that we see coming through are hammered a decent amount into the wood below the surface. So that's why we want to accommodate, let's do this worst case scenario. But for sure, like we're not going to do this every single time, right? Like there's no need to dig into the wood that deep unless we really have to. So the case here is really just designing for that worst case scenario. But the huge majority of the time, it won't be going this deep.
I mean, I can tell you, I think I've shared this before, but you know, when we bring the demo robot to conventions and various places, you know, we have the hammer, we nail it in. When I do it, you know, I am not weak, even though I'm small. I am not weak, and inevitably, there's always someone who comes over and is like, "No, no, no, you didn't get it in there deep enough," and they really just like smack the hell out of it, get it really in there, and then you know, guess what? The robot wins. So
Yeah.
yeah. Just for like the edification of just human monitoring, it's good to have that ability, right?
Yeah.
Yeah, and the truth is, like, you never know what you're gonna get. It's like in terms of fasteners, they're all done by hand. It's like it could be anything. So the more cases you can deal with, the better. And that's basically what we're trying to do here, is like really design this thing so that it's capable of getting as many fastener cases as possible. Okay, yeah, I think, okay, so basically I set these as the like worst case requirements, which are important when you're designing something like this, or like trying to spec out this actuator. And what I was able to do is I was able to you know, like find a bunch of different suppliers who offer this kind of actuator, this thrust force actuator. And a lot of them offer their own tools for helping you determine what the right size of actuator is by plugging in these requirements. And so basically that's what I did, is I went to some of these actuator supplier sites, and I plugged in these requirements. And Andrew, if you go over one more picture to the right to this So basically, this is a velocity and displacement over time curve or plots, and this this basically shows the extend and the retract cycles as I laid it out previously. Um, in the last couple images, and this is basically showing you it's taking the requirements and it's plotting them, and then it spits out an actuator that will work for this case. And also embedded in this information is also the loading, which isn't shown here on the graph. But basically, it takes this, it shows you your displacement and velocity curves, and then it spits out an actuator that will work for you from whichever supplier's site you're on. And basically, what happened is this is from a supplier called Parker Motion, and I've used them in the past, so I've used their products, and I know that I like working with them, and they're a reliable product. So I went here, and they spit out spit out an actuator for me that would work. And Andrew, if you go over a couple slides to that image of that actuator, the one, yeah, that one there. This is basically this one on the left, is a Parker ETH80, which means 80 is the frame size of the extrusion, so 80 millimeters around. It's a bit bigger than that, but that's like the bolt-to-bolt size of the motor mount. And then the pitch being, and it also spits out the right pitch of the screw itself that you need in order to reach the speeds at the loads that we're setting out. And so it spit out the longest lead or pitch option of that. So it's the ETH80 M32, which means for every one rotation you move 32 millimeters. So that's what allows us to get the super fast speeds that we're looking for at the same time. So that's it's pretty exciting. So I did a bunch of due diligence, and then I talked to the people the suppliers who supply this actuator, and I had a meeting with a friend or motion professional named Josh Shimchick, who works at Dynamic Solutions in the Bay Area, and we had a call, and he sized this exact same size that I sized, and he's helping me size the motor and get a quote for this actuator as we speak. So that's kind of where we're at with this option. We looked at some other options as well, but we decided against them because of cost and lead time. Cost, obviously, you want something that works that's as cheap as possible and that comes as quickly as possible. So yeah, we did explore some other options that were capable.
So Josh is helping you get exactly what you need.
Exactly. Yeah. Yeah. So there's distributors who distribute like different, basically different product lines for industrial automation equipment, and Josh distributes Parker Motion products, which is this is a Parker Motion product, and and because he distributes them, he's also an expert in sizing them and helping customers like pick the right one. So he basically,
it's a standard size.
no, this is like a factory made size. You can get, the length can be made to spec, like however long you want the stroke to be can be as long as you want, but for this first one we're just going to order a stock length so it gets here as fast as possible, and it'll work for our purposes.
And when should it be here?
So we're in the process of getting it quoted, which is the first step. So we'll get the quote, we'll review the quote, make sure it all checks out, and then maybe get some other quotes as well from other from some other suppliers, and then I think it's about I think Josh said 4 to 8 weeks, so or 6 to 8 weeks. So it takes a little bit of time to get something like this because it's usually made and then shipped.
I see. Maybe we're not gonna have part 3 in 2 weeks. Is that...
Well, I think that there is some progress that could be made over the next couple weeks, but we won't have it in hand within the next couple weeks. That's for sure.
Okay.
Yeah.
And what kind of progress do you anticipate?
Yeah. So I've been starting to like design what the cell or like the accessories around this actuator are going to look like. And so basically the progress would be like integrating this into the design of the rest of the cell. So that would be the next step to kind of look for.
Okay.
Yeah.
Really?
But I maybe this becomes a 4-part series. I don't know, Jory, because it would be really cool to have this one time where we actually show this thing off.
I would love that. That's huge. Because for me, it's like every couple months I get to see updates. So when I come to the Bay Area, but it'd be really nice audience to really see what you guys have been up to and see it in action, not just a picture, not just a video, but maybe you guys even there's the machine. What are you thinking,
For sure.
Andrew?
Yeah, well,
Can you guys hear me? Am I back now?
Yeah, you're back.
You're back.
I was kind of loop you back
I feel like I've been on the sidelines for this. Yeah.
But normally you say hardware is hard. Maybe maybe the cloud is not so soft or too soft.
Yeah, yeah. The cloud can be a little thunderous as well. I guess sometimes it's just I'm getting slaughtered here. The internet. Yeah. I'm not sure exactly where you guys just left off. Are we talking about like sort of next steps, next episode?
Yeah.
Yeah.
Aidan
We're thinking about.
Go ahead.
Yeah, I think we'll there'll be a little interlude on this one. Jory will probably do a couple more episodes before we circle back around on this, just because of the lead times involved.
Right.
But I'm super excited. I've never worked with an actuator like this before. I think it's gonna dramatically improve the performance of the system. It's just gonna be also just a really beautiful piece of hardware to work with. So I think we're all gonna be buzzing when this comes in, which might be a good fit. It's going to be just about Christmas by the time it's rolling around, so it's a nice little present for the audience.
It'll be a Christmas present for Urban Machine.
Yeah, exactly. Yeah, so it'll be something under the tree for us here for sure. And yeah, we'll unbox that and get it set up, and then yeah, we'll do an episode on the shop floor, and we'll get that singing.
That's what Aidan was saying, but he also had a little brainchild that maybe it's a bonus. We can update the progress because it's not only about this waiting for this part, but maybe the bonus round is to see it in action on the floor. We'll put our heads together.
Yeah, and there is a lot of design around the actuator selection itself, right? Like one of these actuators does not exist in a vacuum. There's mechanical support, there's connection to the rest of the system. Right, there's other motion components here that are helping guide it and support it. So we could talk about those as well. Yeah, we can talk about how it connects into the rest of the system and how we're thinking about that. And then, of course, beyond that, there's the control of the entire system, which we haven't really touched on, and that's going to be sort of an interesting new avenue for us here, because this actuator is going to have a lot more telemetry on it, a lot more knobs that we can turn and performance that we can squeeze out of it that we haven't been able to get on the previous actuators we've been using. So that's another layer that we could peel back on this thing.
For sure.
It's neat to see you guys so excited about something. Yeah, I love it. Anyway,
Yeah, it is
any
super
last
fun.
That's why we're here.
Yeah.
any last information that you guys want to share?
I don't
Yeah,
think so.
that's great. Yeah. Thanks. Yeah, Aidan, the hard work on this. It's super promising. Yeah, and then for the audience, you know, if you want to learn more, urbanmachine.build. We do have open roles, so come check out the website. Check out our careers page. Yeah, jobs are also listed on LinkedIn and well found. So yeah, go find us there if you're interested in working on similar problems.
Yeah, and sharing. I do love that we get the emails that share people's ideas, you know, people's products that people aware of. You know, like Andrew, you said this is the first time you've worked with an actuator like this, so it's exciting to find new things that could fit and building, contemplating building, planning for 4.0.
Yeah, absolutely. And if you're out there building, if you're in the robotic space and you might be looking at similar things, if you want to know more about how we've taken this approach, or you see things that maybe we should be doing better, like reach out, let's have a conversation. Because at the end of the day, this is about getting information out there and just helping us all move down the field a little bit faster to reach our goals.
That's great, for sure. Urbanmachine.build is our website. You can reach out to any of us. Just our first at urbanmachine.build. Yeah. All right. Thank you
Super.
guys.
All right, thank you guys.